Hello dear friends, I am Abha Moria. I am pursuing MTech in Renewable Energy Technology from NIT Silchar. Today I am teaching the engineering physics. The topic that I have chosen is work power energy. For doing work we require force. Let's see what is the force. What is the force? Force is the strength or power that is required to change the position of any object, whether this force is pull or push. I am taking this object, I am applying force like this. This is the push. If I am pushing this object, it goes from this direction to this direction. If I am pulling this like this, so the object going from this direction to this direction. After seeing this example, we can say that force is applied on any direction, and if we apply force of on any object, that we can measure it in unit Newton. So with the force and magnitude any object the this is can say that this is the vector quantity. This quantity is vector quantity. If any quantity has the magnitude and direction both, so we can define is the vector quantity. After the definition, we will go for classification of forces. There are mainly two classification of forces. One is the conservative force, another one is a non-conservative force. Conservative force, what is the conservative force? The work done by the conservative force is only depends on the initial and final position of the object. It doesn't depends on the path followed between the initial and final position. Let's take an example of a gravitational force. ground. This is the ground. I am taking a solid mass and one piece of paper. This goes like this in the ground and this goes like this because the mass of this solid object is more, so it falls speedily. Okay. The height at this point both has the same z1, and at the ground height is 0, z0 is equal to 0. So in the gravitational force, in the conservative force, the value taken in the initial and final, we only take and consider the z1 and z0. We doesn't consider the path followed by the both objects. This piece of paper is followed like this path and this solid mass followed like this path. Okay. So we can say that we only taken into consider the initial and final position of the object. Second is the non-conservative force. The work done by the non-conservative force depends on the path that followed between the initial and final position of the object. Let's see an example. If this is the block and these are the two paths, this is the destination point. We have to drag this object from this point to this point. We have two different paths. We know if force is applied more, then work done is more. So I am taking it is the example of friction force. Because we are dragging. If we dragging more, then friction force comes more. If we follow this path from going this point to this point, then the friction force is more because the path is taken by this object is more. And from going this path, the path is less lengthy as compared to this, so friction force is coming less. If friction force is less, then work done is less. So we can say that the non-conservative forces depends on the paths that followed by the object. The work done by this force depends on the path. Thank you.